In this lesson, we're going to learn how to find the equation of a parabola. What's implied in this is that we'll be given some points. There are really two scenarios that you need to be aware of. We're going to always use standard form, which is y equals a bracket x minus h bracket squared plus k, where the vertex, you'll recall, is h comma k, and a tells me the direction of opening, and it also reveals the shape of the parabola. And well, one of the scenarios is to be given the vertex and a point. What you do in this case is you will substitute the vertex, then you will substitute the point. Now I should just clarify, the vertex again represents the h and the k value, so the point of the vertex goes in for h and for k correspondingly. When you substitute the point, you'll substitute them for an x and a y value. You'll use that to calculate the a value. I'll give you an example of this. The vertex could be 3 comma negative 2, and a point could be 1 comma 6. We start by writing the standard form. We substitute the vertex in, so y equals a x minus 3 all squared, and I see that I put my square in the wrong place. Let me fix that. There we go. Minus 2. Now I put my point in for x and y. So the y value is 6, x value is 1, and you'll see that at this point, the only thing left to figure out is the value of a. 1 minus 3 is negative 2. Negative 2 squared is 4. Let's add 2 to both sides. 8 equals 4a, which leads to a equals 2. And finally, the equation then y equals a, x minus h, all squared, and k. So there's my completed standard form quadratic. Here's the other scenario. You could be given 3 points where 2 have symmetry. A little more work involved here. What we do is we use the symmetric points, and they are going to help us determine the axis of symmetry. And therefore, the h value. That's supposed to be saying therefore. Next, you'll substitute the third point to get a relationship, and that relationship is going to be between a and k. Then you're going to substitute one of the other points and get another relationship. You're going to solve for a, and then you're going to solve for k. This is much more confusing sounding, and we definitely need to go through an example here. So let's say I had these 3 points. I had the point a, negative 1 comma 0, I had the point b, 5 comma 0, and I had the point c, 0 comma 5. Notice the symmetry of the y values. The y coordinate is the same on point A and B. Therefore, we know the axis is at the mean of the x coordinates of A and B. If that's confusing to you, you may want to sketch it just to have a look at it. Mean is the sum of the values divided by how many. So I get x equals 2 is my axis of symmetry. Okay, so the point A and the point B are equally distant from x equals 2. This also tells us the h value. The h value then is 2 because the vertex is always on the axis of symmetry. So now I will write y equals a x minus 2 all squared plus k. So I now know that h value. Now I'm going to use one of the other points. 0, 5 hasn't been used yet. Let's substitute that. 5 equals a negative 2 all squared plus k. This leads to the relationship k equals 5 minus 4a by squaring this and subtracting to the other side. If I substitute that, I can say y equals a x minus 2 all squared, and this is where the k value goes. So I will replace it with what k is equal to. Now I don't have k anymore and I just have a reference to a in two places. Let's use one of the other points, negative 1, 0. Doesn't really matter which one, just one of the other ones. Put the y value in and substitute the x value. And once we've done that, you'll see that this equation has only a left into it. So I have 4a, that's negative 3 squared, or 9a plus 5. If I bring all the a terms together, negative 5a equals 5, therefore a equals negative 1, and therefore going back to k equals 5 minus 4 times the a value, or 9, I now have everything I need. The equation is y equals negative 1, x minus 2 all squared. We knew that before, and we just got the k value. That's it. There are really two different scenarios that can happen in terms of information given and getting the equation in standard form of a parabola.